Hello, everyone. Welcome. Thank you for joining us today. Before we get started, I want to do some quick introductions, and then I want to take you over to Acelab to show you Steel Tube's page, and then we'll jump into the presentation. My name's Kayla. I'm here representing the Acelab team, and we have Casey and Dale here from Steel Tube Institute. So again, before I pass it over to them, let me share my screen. Alrighty, so in just a moment, you should be able to see my screen. We're here on Acelab. So if you're not familiar already with Acelab, anytime you're looking to do some materials research, you can utilize the search bar at the top of the screen. We've got a few different categories here. One of our newest ones is this AI search. It's a really fun way to ask, different prompts, different questions, and do your research that way. However, in this case, to find Steel Tube's page, just make sure you click manufacturers right here. And here we are. So we've got some general information. We've got Dale's contact information right here, front and center. A few value propositions, video, as well as some inspirational photos. So there's a lot of great content on their page. We've also got a link to their website here at the very bottom. So definitely check this out when you have a moment. I will share the link in the chat so that way you can use that. A few other housekeeping items to make note of before we start. We will do Q&A at the end of the presentation today. So if at any point you have a question, you can click the Q&A button at the bottom of your screen. That will open up a box there, drop any questions that you have. We will get to as many as we can at the end of the presentation. You'll also have a poll pop up there. So about 3/4 of the way of the presentation, you'll see that pop up on your screen. It is optional. So if you're not interested in getting any kind of follow-up information, click the X, it'll go away. I can see your screen, by the way, Dale. And yeah, so definitely keep an eye out for that poll, and that'll connect you directly with Dale and his team for some continued conversation. Last but not least, we will also be doing a post-webinar survey. So we really appreciate any feedback you have. And before I forget as well, this is an AIA-approved presentation. So we collected your numbers already upon registration. So you're most likely already good to go in that case. However, if you're worried we didn't get your AIA number, I'm going to put a form in the chat as well. Use that, fill it out to make sure that we have the right number. And that is everything from my end. So I will go ahead and pass it over to Dale and Casey.
Thank you, Kayla. Welcome, everybody. We were right up against the clock on getting my computer to behave today. Technology is not my friend. And so if something happens and we start to have a bandwidth issue, I may turn off my camera to help with that. Our presentation today, we've titled Building Beyond Code, Lifeline Infrastructure, and the Case for Coordinated Resiliency. This is a topic that the Steel Tube Institute was asked by the National Institute of Building Science to develop for their convention or conference that they had 2 months ago, and it went really well. So we updated some with some feedback, and we continued to do our research. And Casey and I are excited to have this audience through our partnership with Acelab to talk a little bit more about that. And we're looking forward to the Q&A at the end of this. I'm going to turn off my camera right here. My name's Dale Crawford. I'm the executive director of the Steel Tube Institute. Just to give a little bit of background about me, I have more of a business development background than an engineering background. So we bring together a lot of engineers within the Steel Tube Institute to help in the work that we do. In addition to running the Institute, I also am work as the director of conduit. So a lot of the work that we're talking about today will be related to our electrical conduit section. And the Steel Tube Institute itself is a trade association representing steel manufacturers, make structural tube, HSS, mechanical tube, ornamental, OEM, and then of course electrical conduit as well. But I'm excited to be with you all and excited to hear your questions, as we get to the end of this presentation. Oh, there we go.
Yeah, this is Casey Robb. I'm helping Dale today in a business development role. I've been working with Dale since we went through COVID together in 2020 and signed a nice little deal to help each other out. And it's all about steel conduit when it comes to these types of programs and talks. And like Dale mentioned, we did this at the NIBS conference in this past May, and the National Institute of Building Science has really geared themselves towards helping design resilience into the fabric of our built environment. And that ensures that buildings and communities remain safe, resilient, and sustainable. And they're leaning into that heavily with this new director and new administration, and we're quite excited about it. Today, we hope to have a collaboration with you on this important mission and to improve resilience in Lifeline infrastructure. Yet before we do, Dale has a personal story to share with you that I think kind of sets the stage for why this is so important. Dale?
So back in 2010, I moved my family to Alabama for work. We're originally from Utah. One thing that's nice about Utah is there's not a lot of natural disasters. Of course, we do have some fire risk in the summer, but and eventually we'll have an earthquake. But tornadoes don't happen here. We have good mountains that they bump into and dissipate. So I moved my family to Alabama and realized I had moved them pretty quickly to Tornado Alley. This picture is my son's second birthday, that little guy. He's now a fairly obnoxious but also awesome teenager that just turned 16 and is terrorizing our small town. But this was his second birthday. Everything was awesome. That's my lovely wife and my daughter that's just graduated high school. Uh, Living in northern Alabama, everything's going good until I come home one day and this is the sky as I'm coming home from work. And that started a 3 day event for us that turned into, well, it turned into a 10 day, 2 month event, really. This is a historical map of the tornado tracks in the United States. As you can see, I moved my family from, this lovely spot here where nothing happens to right here. Yeah, and and quickly realized that we weren't in Kansas anymore, we weren't in Utah anymore, and what we experienced over the next few days, late in April, was an event that impacted a lot of things I do in my life and a lot of the direction I wanted to take my profession. The April 26th through 28th, they call the 2011 super outbreak. It was the largest, costliest, and one of the deadliest tornado outbreaks ever recorded. It's the second deadliest tornado outbreak in U.S. history. You can see the paths of the major tornadoes with the darker color becoming EF5s. We lived just south of Huntsville there in a town called Priceville. So in the end, we were saved, but we didn't know that the whole time. We were hunkered down in our extra bathroom, which was the only room in our house with no windows. Um, Very scary for us, coming from Utah. I never had anything like this. Listening to the tornadoes, the tornado warnings on the news as they progress, and then tell you that something is over your house, some tornadic activity. They can see circulation. They don't know if a tornado's on the ground, and then your satellite TV cuts out, and you don't know if a tornado is coming. Really frightening. Trying to take care of my young kids. Some of you are probably sitting there thinking, I've never heard of this. Dale's making this up. The reason you probably don't remember this or haven't heard of it is the news cycle that weekend got commandeered by the uh, the killing of Osama bin Laden on May 2nd. So that is why it's a little bit lost to history. The area we lived in had a lot of chemical plants and steel plants along the river in Decatur, Alabama. This is what the riverfront looks like. Across the river and down a little ways is a TVA nuclear plant, Browns Ferry nuclear plant. it was hit by AIA-4 earlier in the day, and we knew it had sustained some damage. Later on, a lot of the issue with it was the transmission lines coming out of it were damaged, and nuclear plants can't run if they can't transmit out, and they had to do a controlled shutdown. But none of that was known. None of that was known if there was damage here or damage here. And we hear that this tornado is heading for us. This is Coleman, Alabama. Um, we see this on the news. This was broadcast live as it was happening, and this was something that we were right in line for it to hit us. And then we hear an announcement over the PA system in our small town saying that there has been a chemical spill in our area and we need to evacuate immediately. So we go outside because in between the storms, it's pretty calm, really ugly skies, but pretty calm. And I start thinking of everything we need to throw into our van, put my two kids in, and just in a panic, trying to keep my family safe. And there's some other people in the neighborhood that come out of their house, and we're talking, is it really a chemical spill? And then they repeated the message. We're thinking about all of this nuclear plant, we're thinking about these chemical plants, and we are just about a couple months removed, maybe 2 months, 1 month removed from the Fukushima disaster that happened in Japan from that tsunami, where it ended up being a nuclear disaster. And we were hearing news about some people who evacuated are never going to be able to come back to their home. And so this is what's going through my mind, as a dad, keeping my family safe. And in the end, one of the neighbors was able to get a hold of the sheriff and find out that it was a mistake that they played that message, which is still unbelievable to me in my mind. And they never played like a retraction message or anything like that. And we saw some people in our neighborhood leave with these tornado tracks happening on both sides of us. So we were okay. We were able to stay put. We were able to make it through that night. This was the cleanup in the days following. This house here was across the street from a house that I was assigned by my church to go and help. And unfortunately, this was a family of 4 that was lost. The house just pancaked right down on the main floor. All we could do was walk over and lower their flag to half mast, and so that is what we did. I tell this story not to start everything with a downer, but just to talk about. Let me go back one. Just to talk about why this is important to me. We're talking about resiliency here. We lost phone lines for weeks. We lost power for 5 days. 60% of the loudspeakers were knocked out, and there was no warning issued to some of these areas. Resiliency takes a coordinated effort. It takes looking into the future and thinking about what could happen and what can we do about it with both the built environment and the communities surrounding it. And that's what we want to talk about today, because the work that we do in the construction market and the built environment, it can save people's lives. It absolutely can, and that's why it's important to me. And that's why this program is important to the work we do at the Steel Tube Institute and to me personally. Casey?
Thank you, Dale. I think it's obvious that everybody on the call, we're all seeing more and more natural disasters, and communities are facing increasing pressure to deliver resilient, future-ready buildings. And this intersection between resilience in buildings and the lifeline infrastructure that connects us to our communities really does need additional research, focus, and policy. And that's why Dale and I are so proud to be a part of NIBS, because they're leaning into this heavily, and they're leaning into it actively with our current administration. And a new director has been hired to help us do that. So we're really excited to be a part of that. Today's presentation, we're really going to explore the critical connections between buildings and essential systems like power, water, telecom, and transportation, all framed through the lens of lifeline infrastructure resiliency. Using steel conduit as a case in point, we'll examine how to move from just meeting code minimum to designing for long-term reliability, resilience, sustainability, and adaptability. Now, that's not to say it doesn't come without challenges, but we really think it needs focus, and we think the architectural community can help in that dialogue with owners, developers, and communities around the country.
So let
Dale?
me review our learning objectives here. STI is an approved provider of AIA CESLU credits. This program qualifies for 1 learning unit credit and is approved for an HSW. We'll focus on the following learning objectives. First, we'll redefine Lifeline Infrastructure and its role in making communities more resilient. We also plan to showcase steel conduit and high-performance raceways as an example of Lifeline infrastructure that can impact long-term resilience of both the buildings and the critical connections we have within our communities. We'll also highlight behaviors to move us from code minimum and how going beyond code is the only logical path forward. We will highlight public policy opportunities and other actionable strategies to support Lifeline infrastructure planning and strategic infrastructure investments and implement more robust Lifeline infrastructure for the built environment. Casey?
And I think together we can act upon influential strategies through our organization. We're trying to do that actively. And we need your help to provide actionable strategies for owners, developers, design build firms, engineers, and design professionals as a whole.
Thank you.
You know, the term, what is Lifeline infrastructure? The term was new to me going into this year, and I really am glad that Dale asked me to help join him in this pursuit. The term Lifeline infrastructure has been around since the 50s, back when we started experiencing more and more earthquakes, especially as we rolled into the 70s and 80s. You'll remember a lot of the earthquakes we had out in California that really impacted our infrastructure there. This was a global phenomenon. They had global committee work that started working on the Lifeline infrastructure support system around earthquakes. And now today we're having so many more natural disasters, the meaning has expanded to a much broader audience and a much broader community. It's now taken on a global correlation with catastrophic disaster recovery due to climate change. And this has brought attention to the fact that buildings don't exist in isolation. They are part of an interconnected infrastructure ecosystem, and they're critical to the health, safety, and welfare of our lives. And it really is important. As you see this chart to the left, I really first looked at it and I thought about the 6 degrees of separation. Thank you, Kevin Bacon. This chart kind of shows you how communities must connect with power, water, housing, communication, transportation, and healthcare. And all buildings and communities they critically rely on these elements to successfully make it through their life structure and any kind of disaster. So mutual dependencies mean a fault in one lifeline can cascade to other services. And when designing for more durable lifeline infrastructure, resilience of these systems becomes paramount. And that means we're going to have we're going to continue to have more disasters, but we got to really think about this to have quicker, faster recovery and get back on our feet. You know, even back in May when we did this program, on Mother's Day, we had an earthquake right here in Georgia, and parts of me think it was my mom up in heaven telling me just wake up and lean into this because it's an important topic. Next slide is, of course, FEMA. We have FEMA with their community lifelines identified, and it takes our 6 degrees of separation into a full 7th degree. And just as Dale said in his example, you know, the community faced hazardous materials through leakage that happened at a chemical plant. That can really lead to some problems. And so that's the additional point that hazardous waste has really been a focus with FEMA. So it's unfortunate, but we can't take that for granted. Let's frame the issue out a little bit. Let's talk about building beyond code and why that's becoming the new baseline. You know, with each iteration of the IBC and its eventual adoption over time by state and local agencies, it will incrementally move us towards increased resilience of buildings themselves. Waiting, though, on these slow processes on a 3-year cycle just isn't sufficient enough to impact resilience of our communities and even some of the sustainability strategies we're trying to embrace as we move forward. Even if we jump up to the upcoming IBC 2024, going into effect in 2026, which is exactly what they're adopting here in Georgia, we might have more resilient, durable, and sustainable buildings and strategies for those buildings, yet we're missing the mark on the Lifeline infrastructure resilience topic we're talking about today. So public policy is missing, and the interconnection to more robust Lifeline infrastructure and recovery strategies is needed. Both codes and policies must be addressed to meet the higher level of resilience in our buildings and these connections with our communities. Does anyone not disagree? I mean, go ahead and put a comment in the chat and we'll try to address it. But this is the avenue that we're taking in this approach. This slide is another one by FEMA. The Federal Energy Management Agency explicitly emphasizes minimum building codes are simply not sufficient to address the risk posed by today's frequent and severe disasters. And you know, with the recent cuts in FEMA, there's no way that minimum codes are going to get us to where we need to be. In essence, relying solely on minimum standards leaves the communities significantly vulnerable, and it is vital to move beyond these minimum codes and adopt advanced resilience codes or measures. These advanced measures must include better redundancy and crucial pre-planning, and there's some really interesting things that are out there to give you the framework for this pre-planning effort. We must consider going beyond code to adequately safeguard lives, property, and economic stability against the unpredictable nature of increased disasters that are happening out there among us. Let's talk about building and building beyond codes. We know natural disasters are becoming more frequent, more damaging, and not just earthquakes. This is across the board with wildfires, with floods, with hurricanes, with tornadoes, you name it, we're seeing more and more of it. And we think it's directly attributable to climate change. These essential services that connect us all must be improved and protected so that functional recovery can then accelerate to return our communities to pre-disaster service levels. Strengthening Lifeline infrastructure connections through resilient solutions like steel conduit can improve reliability, reduce downtime, and enhance safety. As an example, if you're building a nuclear power plant, which I worked on right out of college in my early career, you basically have a city within a city, and that involves lots of steel conduit. In fact, that's the only way you can build nuclear or coal-fired power is to use steel conduit. So why aren't we looking at that more in today's built environment when we want a 100-year design life cycle? So we'll talk more about that. Next slide. This really looks at the difference between building codes versus the potential for infrastructure codes. And if you look at building codes today, life safety and basic structural performance is really addressed by the building codes. But there is a potential for infrastructure codes to basically help the communities functionally prepare for disaster resilience. The scope, and with building codes today, it's individual structures, homes, offices, etc. But with potential Lifeline infrastructure codes, they can become more interconnected systems with power, water, transportation, etc. With performance, we talk about safe evacuation and avoid collapse in today's building codes, but we need to talk more about prioritizing operational and recovery systems and rapidly recover from disasters. These update drivers, yeah, the building codes were impacted by past disasters. Look at Hurricane Andrew in 1992 down in South Florida, for example. What happened out of a result of that? The Dade County hurricane codes, it updated everyone from structural glazing to ballistic requirements on glass, hurricane strategies, and then shingles, roofing, all these things got upgraded in our codes. What's not happening today is the risk modeling and the continuity planning needed for national security, for more increased disasters, and we'll talk about that in our program. The primary focus, though, around building codes is to protect occupants. The primary focus around the potential Lifeline infrastructure codes would be to maintain community lifelines. So shifting from individual safety to community resilience really does become important as you think about the potential for infrastructure code improvement.
So as part of our program here, we wanted to deliver a case study and a case in point and highlight, the product category in which we're representing. Because it's a great category, and this was actually brought up by the NIBS and why they asked us to do this, because they had learned a little bit about the work we do. And they're like, this is the perfect product category that has a connection within the buildings and within the communities in which they reside, that if we build beyond code, it results in a much more resilient community. And so I wanted to walk through, I'm going to do this pretty quickly, but the highlight of the product category, product features really of steel conduit that can help here. Steel conduit can be used per code in every application, but there's some where cheaper materials are used to the detriment of the long-term viability of the project. To be fair, there are other materials that may be a better solution, like plastic or fiberglass, in an open air application near the ocean, or some buried applications with acidic soil. You might be better off with PVC, and MC cable is a great solution for a final connection to lighting and a drop ceiling, some of those. But the resiliency in the majority of it, there's a steel conduit solution that should be looked at for resiliency. And I'll talk about why. Steel conduit is the strongest electrical raceway on the market. It protects against piercing, crushing, breaking, etc. It protects in cases of natural disasters and intentional sabotage, which is increasingly becoming a concern. It allows for the easy addition and replacement of conduits, which provides for future proofing. Upon installation, conduit can only be filled to 40% of its conduit fill, which allows you to pull in additional conductors later. You can pull out conductors as the needs of the building change. And we'll talk about a little bit of a case study we did that illustrates the financial side of that here in a minute. Steel conduit provides substantial fire safety advantages because it's inherently non-combustible. Like other materials, steel conduit requires no additional fireproofing measures. This characteristic ensures that the wiring remains fully protected during fires, reducing the risk of flame and smoke spread. Consequently, this allows additional crucial time for evacuation and emergency response, significantly enhancing overall safety during fire events. EMI protection, electromagnetic interference. This is something a lot of people in the built environment aren't looking at, but those that work in critical communications, critical infrastructure, healthcare environments, places with sensitive electronic equipment, it's becoming more of a concern. And for many of them, it's been a concern for a long time. Steel conduit serves as a highly effective shield against EMI. The Steel Tube Institute has done extensive research with experts at Georgia Tech, showing the EMI mitigation being 99+% on steel conduit, where other materials, it's somewhere in the 50 and 60% with MC cable, and negligible, of course, with plastic or fiberglass. This shielding capability ensures continuous and reliable operation in environments that are highly dependent on technological systems. So now to give some applications of some actual settings in a healthcare environment. And the reason we talk about these in particular is because there's a case study on the Steel Tube Institute website for each one of these. And so it's called Operating Room EMI Mitigation. I give the names of each of these of the next 3 slides. Operating rooms require exceptional stability and protection from electrical magnetic interference to maintain the integrity of sensitive medical equipment. Utilizing steel conduit effectively shields equipment from EMI disruptions, ensuring continuous, uncompromised patient care environments with increasingly sophisticated medical technologies. This is becoming even more of an issue and something that needs to be looked at with multi-purpose buildings, more distributed healthcare out into the communities, where you're going to see a lot more healthcare environments closer to where we live, less centralized. Public safety infrastructure, such as police stations, emergency operations centers, fire stations, they demand robust, adaptable wiring solutions capable of configuration as needs change. Steel conduit provides that with superior physical protection and flexibility. for swift, cost-effective modifications or technological upgrades. This adaptability ensures continuous operation and functionality readiness during critical events, like that tornado that I talked about. Imagine when the fire department and the emergency services can't function. That's a huge deal in the community. And then final case study, we have one on a data center. Data centers manage vast amounts of highly sensitive and mission critical information, making uninterrupted operations essential. What I learned during the tornadoes is we had gotten rid of our landline, and my boomer mother was upset that we got rid of our landline at that time. That what if there's an emergency? Well, the cell phone towers actually lasted, the landlines did not. And with the phones that we have now, you need a lot of the capability from data centers. It becomes increasingly important. So onto this particular case study on the financial side of this. What we hope to point out, and this is true of so many other products as well, is that you don't have to look at the entire life of a product. Sometimes you just have to look at 5, 10 years, and the more expensive initial cost will save you a lot in just a couple of years. So that is what we aim to do with this scenario we put up, where we compared MC cable versus EMT, which is the cheapest thin wall product that is a steel conduit product. And in the end, we showed over a 10-year life of this building, having gone through a couple of circumstances that are very reasonable that could happen to any building. There was a $33,000 savings, including the initial install being more expensive. I know this graphic is a little hard to read. It's a little bit of an eye chart. You can find it on our website, but I'll walk you through the numbers on the next slide. But just to walk you through the circumstances we took them in, the initial install was more expensive on steel conduit, but in year 4, say there's a short circuit, which does happen. There's some issues of product being installed and things getting torn, and there's a ground fault. You have to pull out the entire cabling if that happens. And when that happens with conduit, you don't have to take down all of the drywall, all of the finishings. You don't have to, dig into the structure of the building that you would with MC cable, which is an installed in place product. And what you install is what will always be there. All of that has to be torn out. So a short circuit in year 4 makes a big financial impact. In year 7, there's a light conversion to this 4-year, I didn't mention this is a hypothetical 4-year, 4-story office building or multi-purpose building that one of the tenants needs to convert one of the floors to some light R&D. That takes additional power and different needs of the building, and that makes a difference. In year 10, there's a healthcare conversion, like I just talked about. We're seeing more conversions happening in more places because that is where people want their healthcare closer to where they live and work. And a healthcare conversion has completely different needs, power-wise, and many of the parts of a building. And so showing the numbers here, you can see the initial install, it was $4,000 more expensive with EMT. But then any one of these other products or instances results in a more resilient product being much less expensive. And any one of them could make the difference in overcoming that $4,000 initial install. We illustrate this because there's so many products just like steel conduit, where it's not the sexiest, it's not the flashiest. I don't wake up every day and do my job and think that I can't believe more people aren't loving and thinking about steel conduit all day. That doesn't happen. But sometimes the oldest product on the market is still the best solution and the most resilient solution. And that's the case here. We want people to think, and you don't have to think very far in the future to realize the resiliency of some product categories. I throw this up here just to illustrate that there are so many places where a product like this connects to the communities. This shows all of the places where there's connections to the communities and the different types of applications we have within a community. And this is also on our website if you'd like to look at this chart closer on the steel conduit portion of our website. Casey?
Thank you, Dale. I think I wanted to also recap that for those of you out there as design professionals that are specifying these more robust materials, such as steel conduit, this website is an invaluable resource to help you defend your design decisions. I know you're going to go through a lot of challenges with cost, with the different parties you have to talk to through the design development process. Steel Tube Institute is here to help you defend that decision. We're also here to help you specify it. And this fall, we should have our first ever STI guide specification for the use of high performance raceways. And steel conduit is your answer for those kind of jobs. But let's get back to connecting buildings to communities. And that's really where we want to focus now. And this slide was actually captured at the NIBS conference and put into some various publications because it just gets right to the bullet point of how Lifeline Infrastructure is the integration point for community and building resilience. Buildings function through these critical connections within a broader infrastructure network, and improving resilience is essential for this viable continuity of community services, especially during disasters and disruptions. Next slide, we have these connections to buildings and the role of resilience planning. There are some great guidelines out there, and I want to make the case for these systems can be involved in community discussions. And I want to give you an example of the city of LA. We met them at the NIBS conference, and they basically took the NIST Community Resilience Planning Guide and the FEMA Functional Recovery Guide, and they had hearings with the city to come up with their own public infrastructure and disaster mitigation program. This takes community involvement. This takes some serious decision making as to what to prioritize when a disaster hits. And this is not an easy process. And to hear the city of LA go through just how they took these nationally available guidelines and took them into the community planning, oh my gosh, it was a real eye opener as to what your voter base really finds as needed and necessary versus what you as a city finds needed and necessary to recover from a natural disaster. Hard decisions have to be made, just like the example they set with the recent fire disasters in Southern California. That took a real effort to prioritize what priority went first. So it's a big deal to have this planning done in advance. So I will again reference the National Institute of Standards and Technology gives you community resilience planning that you can use in your planning with urban planning with developers and owners.
Yeah, we wanted to give some examples of lifeline infrastructure, in the wild, and how a product like steel conduit has an application for resiliency beyond just building projects. First example we have is related to corrosion in coastal settings. Hang on, I'm gonna skip this one. Industrial and transportation environments often subject infrastructure to significant mechanical stress or vibration, risking wiring integrity and operational continuity. Steel conduit's robust construction provides unmatched physical protections we've discussed over and over. This resilience ensures uninterrupted functionality, durability, and safety across demanding operational contexts. Exposure to chemical and industrial settings. Electrical systems and industrial environments routinely face exposure to harsh chemicals, potentially compromising standard wiring systems. Stainless steel conduit in particular resists chemical deterioration, offering exceptional longevity, reliability, reduced life cycle maintenance costs. Its chemical resistance ensures continuous infrastructure safety and performance, even in hazardous industrial conditions. Urban electrical systems can experience overheating risks, increasing potential for fires and system failures. Steel conduit withstands high temperatures, as we've discussed, significantly reducing those fire risks and ensuring structural integrity. This characteristic enhances overall public safety by maintaining that reliable and secure electrical infrastructure in dense urban areas, like we saw with the example in Southern California that Casey just brought up. Achieving effective resilience necessitates a strategic balance between mandatory codes and voluntary incentives. I want to note this first bullet point: that buildings account for 30 to 40% of primary energy consumption. While mandates guarantee baseline compliance with essential resilience standards, incentives encourage proactive adoption through minimum requirements. Combining these approaches promotes widespread implementation, fostering higher quality outcomes and broader stakeholder engagement in resilient infrastructure practices. And that's so important, especially in the application that we're talking about, and looking about how much of the energy consumption comes from buildings. And it's just a great example of the voluntary incentives going beyond mandatory codes have been successful in trying to mitigate that energy consumption. We're going to talk now about public policy and infrastructure investment and where we see that going to help in this goal here. This poll just popped up in front of me. Okay. Sorry, get back to that. There we go. Sorry, I got distracted by the poll. Federal programs significantly enhance community resilience through targeted research funding and infrastructure grants, breaking financial barriers that otherwise hinder innovation. These initiatives drive technological advancement, provide community practical resources, and financial feasibility to proactively implement resilient designs. Such federal support is crucial for scaling infrastructure resilience and advancing national preparedness. Stricter regulatory mandates for resilience enforce uniform, higher safety, and performance standards across infrastructure sectors. These mandates significantly reduce systemic vulnerabilities, ensuring consistent preparedness and reduce the risk of catastrophic infrastructure failures during severe events. Regulatory clarity and consistency are vital for ensuring robust, community-wide resilience and sustained infrastructure reliability. Casey?
Yes, let's talk a little bit about digital twin adoption. I don't know how many of you online are familiar with the digital twin approach to buildings, but NIBS and the organization itself has looked into this in a very deep and robust way. They've had several presentations on it. I actually got to experience firsthand with a trip to Tampa last spring in Florida. A firm by the name of Hoyt Architects has adopted the digital twin technology for the whole new waterfront in downtown Tampa. And this has allowed them to make a significant investment in literally not only just the buildings themselves, but the entire waterfront and the applications where they can actually determine community connections and the effects of disasters will have on those buildings. So it's a really classic example of how digital twins can allow simulation of infrastructure performance before construction, helping you identify risk, optimize designs, and significantly advance overall resilience and operational effectiveness. This advanced technology should not be overlooked. Its approach minimizes potential failures. It streamlines decision-making process for safer infrastructure development. And I know firsthand that Hoyt, in their example at the waterfront in Tampa, has taken this technology public now and is offering it as a service to many design firms and professionals around the country.
We wanted to just highlight the growth of data center infrastructure in particular because it's so critical to everything we do within resiliency, everything we do in the technologies that we now use in everyday life and in the built environment, but also because of the vast amount of energy it takes. We found this chart or this map from NREL. Very interesting. This isn't a map of the interstate system in the United States. Those lines are transmission lines, with the darker color being higher voltage class of transmission lines, and then the dots showing where there's data center demand capacity in megawatts. The larger the circle, the more demand there is. The orange is under construction, the white opaque color is proposed, and the yellow is operating. So there are some big projects under construction, and there are even more, even big, larger projects that are planned at this point. Data centers are a critical hub, managing vast amounts of sensitive data. And with our example in our case in point here, steel conduit creates a Faraday cage around wiring, significantly reducing the EMI risks and shielding against the physical protection that it needs there, preventing overall issues in damage and in sabotage, which is an increasing concern, especially in the world of data centers. Another example of some unique public policy that has worked in choosing steel conduit in particular is the Chicago Electrical Code. The Chicago Electrical Code sits on top of the National Electrical Code as an amendment. And though steel conduit is not typically used in residential construction, it's actually required in Chicago homes. Steel conduit is most commonly used in commercial and industrial buildings. However, on the residential level, non-metallic cable is more widely used. NMB or Romex is one of the trade names. But there's one oddity in the United States. Again, it's Chicago. After the Great Chicago Fire of 1871, Chicagoans are very concerned about fires when you go there and you build there. There's other benefits here, though. A study by the Chicago Fire Department showed that Chicago experienced nearly 4 times fewer residential electrical fires than found nationally. The Chicago Electrical Code makes amendments to the National Electrical Codes that require the steel raceways in all homes. So while most homes in, say, Colorado, Chicago, Georgia, Utah, where I live, utilize that NM cable, Chicago uses the conduit. And because of conduit's ability to be reused, this means that a home that is undergoing renovations in Chicago can have wiring replaced in an afternoon. I have video of a home for an elderly person, an elderly widow. The entire wiring in her very old home was replaced literally in an afternoon by the local electrical union there. And it was a great project, a great charitable adventure, but it was also a really good case in point showing that drywall and finishings stay and don't have to be replaced. Again, just a great example of how it can connect with our community and have greater resilience by the product and the materials that we select.
Yeah, well, I'd like to talk a little bit about green building frameworks. Since I am a lead AP, I really have a passion for green building, and these frameworks integrate recycled material standards and sustainability goals into our construction practices every day. The other thing I wanted to mention while we have this slide up is that when you use American-made, US-based steel producers, you're leaning into a more sustainable steel production. Up to 95 to 98% of steel production in the U.S. is based on the electric arc furnace. It's based on recycled use of materials, and it's also the forefront of alternative power and what we're looking at using to fire these kilns and to make steel. So there's some really advanced things going on at the Steel Tube Institute with our members and in providing a more sustainable approach for steel production. This drive to also improves our resilience and environmental responsibility, and these frameworks align very well with construction practices for sustainable development goals. Let's talk about conclusions, Dale. We got about 10 minutes left here, and I think we're
we'll jet through here so we can get some questions here and start loading up some questions in the chat if you have some or some comments there. The goal of the session is to highlight the role of Lifeline Infrastructure and how it plays in community resilience.
Yeah, and I think clearly understanding Lifeline Infrastructure versus individual buildings is really important. And it's also essential to understand these are going to affect our resilient strategies and developing those strategies in the future. So These systems include power, transportation, water, and telecommunications, and they serve as the backbone of community stability and functionality. And I think the strong interconnection between buildings and community infrastructure simply underscores the importance of integrated resilient strategies.
Again, steel conduit is a exemplary model of practical resilience due to all of the features that I won't belabor any further. But these characteristics collectively make a product like steel conduit an ideal and robust solution for resilient infrastructure projects. And we need to be looking for these type of products out in the marketplace. And those are the things we want to be specifying, because there's reason to have certain materials, and we need to be strong in the way that we're specifying them so it carries through the entire value chain down to the installation and doesn't get value engineered out. There's
Yeah.
so many cost saving things that happen in the name of value engineering that doesn't bring value and only bring cost savings, and sometimes it's just taken by the end contractor, and we don't want that to happen.
This really does require us to have a coordinated action among developers, engineers, design professionals, and policymakers. Owners and developers must prioritize these strategies and really focus on rigorous testing, collaborative approaches, and a resilient, focused design. Also, as design professionals, we need clear, coordinated, and explicit construction documents. And our policymakers need to provide clear, supportive regulatory framework that encourages innovation and community resilience. These combined efforts lead to robust, adaptable infrastructure capable of meeting the future challenges we all face.
In closing, proactive resilience planning and targeted infrastructure investment are essential to prepare communities effectively for future uncertainties. Through clear identification and strengthening of lifeline infrastructure, implementing practical solutions such as steel conduit and other products like it, fostering integrated community building resilience, and advocating for supportive public policy, we can collectively build stronger, more resilient communities. Thank you all for your attention today. I did have to skip one or two slides in the interest of time. So if there's anything you skip that you want to learn more about, just reach out to me, and we appreciate your time very much.
Awesome. Thank you, Dale. Thank you so much. And Casey, that was a really great presentation. I did have a few questions that came through on my end, so I can go ahead and jump into some of those, and we'll see if any more come in as we go through that.
Okay.
Let's see here. Somebody asked, what's the business case for investing in enhanced steel tube resilience beyond the code requirements?
Hmm.
Yeah, I think the business case really comes in looking beyond the initial install, and looking at the flexibility that you have in the project, and just looking beyond the initial install. And the building owners want that, and the architecture firm, but it's when you get down to the general contractor and electrical contractor level, sometimes that desire gets diluted. And so making sure that that carries through, that's key there.
That's also important to think of this beyond a commodity role. It's important to think about it from a resilience and design life cycle role. And once the design professional understands the advantages to steel conduit, and you can interpret those and articulate those in some of your as you go through the design development process, you can put an end to the people out there trying to value engineer this to something else that may not be more appropriate for long-term resilience in your building program.
Absolutely. Perfect. All right, another question just came in. Buildings that go beyond building codes are currently de-incentivized locally. There's no recognition for living building challenges, ease on grid or water systems. What tools exist to help local designers or project leads argue for city support or financing to help improve acceptance of an infrastructure resilience approach?
It's a little tougher challenge. Dale, you want to try to take a crack at that?
Well, the tools that are available are probably looking for associations and nonprofits, non-governmental agencies like NIBS, like the Steel Tube Institute, and seeing what resources are out there. But going beyond that, this is what we're trying to develop, and this is part of the program that we're partnering with NIBS on, is developing those tools and giving a toolkit out there. And we need the market's help to do that. So just your question there, Christina, provides me some information that I can take back to NIBS on the efforts that we're trying there. So communicating with organizations like us, telling us what is going on, what are you hearing, what's the scenario, what is being asked for, and what would be most helpful. It helps us to help you in the future.
Yeah, and I think I don't know if you heard this earlier as a participant, but the NIBS organization just had a meeting with Congress on Lifeline Infrastructure and started the process around what we're talking about here today to get more buy-in to the resilience strategy rather than just focusing on one or two issues around sustainability. I think too that your local this issue can be driven locally by belonging to owner developer type organizations, for example, COA, or some of the bigger organizations that involve owners who are passionate about doing this. I just came back from a green data center conference, and to talk to the owners that are building these data centers, green matters, sustainability matters, alternative energy sources matter to them. So they're stepping up their game to drive these behaviors. And I think that's what it takes when you look at the building communities to see where that driver's at and get involved with those drivers, because that's the only way it's going to happen. Lowest common denominator is not going to get us to where we need to be tomorrow.
Absolutely. Well, thank you for that. That was really great. And for the sake of time, I think we can go ahead and stop there. But folks, if you have any additional questions, feel free to drop it in the post-webinar survey that's going to pop up. And then also keep an eye out for an email coming from no reply Acelab email address after this. If you did fill out the poll, that's a great way to get connected with Dale and Casey and get any further questions answered there as well. So keep an eye out for that. And any final comments or notes before we wrap things up today?
Yes, on the learning unit, you'll either hear from my assistant, Stephanie Fontaine at Steel Tube Institute, or you'll hear from ASAP. I don't know how that ended up, how we were going to handle your certificates, but they will come. And they'll come either from Acelab or Steel Tube Institute. We're both accredited to issue your learning unit, so we'll figure out the best way to get that to you. But thank you all for coming. Thank you for your participation. I hope you have a great summer.
Yeah. Thank you again. Appreciate
Yes.
the opportunity.
Yeah. Have a good one. Bye.
We'll be in touch.